will study each conic section in detail later in this chapter. Even before you learn the characteristics and equations of conic sections, you can identify each curve by its shape and features. The center, the vertex, and the intercepts are important points to identify on the graphs of some conic sections. Example problem 4, identifying graphs of conic sections. What are the center and intercepts of each conic section? What are the domain and range? Well, first considering the graph A. Well, right away we notice we have a hyperbola, and we're asked to identify the center. Well, this hyperbola seems obviously centered at the origin. We're also asked to identify the intercepts, so now we're searching for any x or y intercepts. Notice we have x-intercepts at both -2, be careful of the units, -2 and +2, and no y-intercepts. What are the domain and range? Note our graph is not defined on the domain values of, well, anything between -2 and +2. So its domain, which can be stated this way, this just means x is an element of the set of real numbers, so all real numbers x, such that x is greater than or equal to 2, or x is less than or equal to -2. Basically that all says what I think we will probably find below right here. The domain is the set of real numbers x with x is less than or equal to -2, or x is greater than or equal to 2. And our range, well, our hyperbola will take on all possible values of y, so our range can be written as all real numbers, or simply said, y is an element of the real numbers. And graph B, well, graph B is an ellipse, right? The oval shape we call an ellipse. This ellipse is again centered at the origin. We this time have 4 total intercepts, an x-intercept at +6 and another x-intercept at -6, y-intercepts at +4 and -4. So we've covered the center, the intercept. Now the domain and range, well, so using our fancier notation, the domain can be stated as all real numbers x such that -6 is less than or equal to x, which is less than or equal to +6, and our range can be stated as all real numbers y such that -4 is less than or equal to y, which is less than or equal to +4. And a chance to show that you have got it. What are the center and intercepts of the conic section? What are the domain and range? Work carefully and make your selection from the choices below. Example problem 5. Using models. 2 patterns, such as arrays of dots or lines, can overlap to form moire patterns. In the diagram, what pattern do intersecting ripples form? Which of these equations is a possible model for the pattern? X squared minus y squared equals 1, x squared plus y squared equals 16, or 25x squared plus 9y squared equals 225. One of the first things we need to do is identify which type of conic section we're dealing with in this moire pattern. And a side note, if you would like to do a quick image search of moire patterns, you'll find some pretty amazing art and math. Anyhow, it looks as though these intersecting ripples, well, they form circles. I imagine if you look closely, you'll see the circles that are formed by the intersecting ripples. So our next step is to identify which of these equations represents a circle. As we saw before, the equation x squared plus y squared equals 16 forms a circle. And the other 2 equations do not. Therefore, we have found our solution. And a chance to show that you have got it. Unintended moire patterns cause problems for printers. Describe the unintended pattern. Which equation is a possible model for each pattern? X squared minus y squared equals 1, x squared plus y squared equals 16, or 25x squared plus 9y squared equals 225. And your lesson check problems for section 10.1.